Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is little different, little interesting MCQ. So I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now what is the major product of these reactions? So if you look at here that magnesium anhydrous ether in the first step, and this side there is a 3-member ring with a Br. So from there you can understand there is actually a carbon halogen, actually Cbr bond. So magnesium anhydrous ether means it's a Grignard reagent preparation. So in the first step what it will result, this is a double bond pH, this is Mg Br. Now this is MgBr. If I say, remember this is actually a carbon ion. If you say a 3-member ring attached to this is magnesium, so magnesium is more electropositive. This carbon is not that much electropositive. It is neither electropositive nor electronegative, like that. So actually generally close to 30 to 40% ionic character exists in this covalent bond. So like that. So what happened, you can consider this is actually a carbon ion type. So what can happen, this pair of electron remains in this sp2 hybridized orbital. Now here in the next step what is possible? By the way, if you look at this bond, it is, you can say, sir, it's a CC bond, it's a sigma bond, but it is not a strong or stable bond. Why? Because look at the next carbon, this is sp2 hybridized. So generally for sp2 hybridization the expected bond angle value is 120 degree. So it is expected 120 degrees. So what is the angle here? Nearly 60 degree. So you can say there is a very high, or you can say severe angle strain. Now angle strain makes the molecule relatively less stable. So remember why a molecule does a chemical reaction, in order to attain stability. So target is to attain stability, and here there is a strain. So molecule will obviously prefer to remove this strain. How it can? So this lone pair is given and this bond opens. By the way, both sides are same, so it doesn't matter which side will open, same, meaning is same. So ultimately here what will be the product? So I suggest in this case student draw as it is, do not try to do any modification. So this is the negative charge. Now it was a carbon ion previously, right now this is, and if you want to not to say okay sir I don't want to say it's a carbon ion, you can say here this is your new MgBr. So you can say this is a rearrangement of Grignard reagent. Now what is the benefit? Benefit is that ring strain, look at, it's a straight chain compound, so the ring strain part is gone. And now you may think, sir, can't this directly react with this aldehyde and produce the product? That is, student, this is an intermolecular reaction, but this rearrangement is actually intramolecular. And remember, intramolecular reactions are faster than intermolecular. So this step will happen very fast. And now obviously this is the carbon ion. Okay, this has a bond with magnesium. Now this part is a delta negative, you can say, so it will act as a nucleophile and it will attack this formaldehyde. By the way, formaldehyde is called as super electrophile, or you can say very high electrophile. Why? Because in this formaldehyde molecule this carbon is attached to oxygen. This is delta negative, this is delta positive, yes, electronically, and by the way there is hydrogen, so no plus I effect. So this is electronically, this is activated, this carbon is electron deficient. Another thing, steric point of view, very reactive. Why? Because hydrogens are the smallest atom. So consequently this side can attack here very efficiently and it will open up. So what is the product? Now student, write as it is, do not need to make any modification. This is C. Now this is here next CH2O minus. By the way, look at, after this carbon there are two carbons. So after this triple bond there is one carbon. So carbon number matching is very important in such reactions. So actually mistake is done generally in case of carbon number matching. Okay, now obviously in order to maintain the electroneutrality, this MgBr part remains there also, close proximity. Now last step is hydrolysis, means breakage of these ionic entity by water. You may consider this is water as HOH, and here these H is delta positive, OH is delta negative based on the electronegativity difference between this hydrogen and oxygen. So this OH bond is polar. Now these delta H, this proton is abstracted by this, and by the way, there is a H plus, so it is not that much difficult. So these will abstract the H plus, that's more accurate. Okay, so fine. Obviously what happened, this pH part, C triple bond C, I am drawing now little better. CH2, CH2, again another CH2, 3 CH2, then OH. And what is the fate of magnesium? Obviously MgOH-Br, magnesium hydroxybromide. So this is the product of this reaction. I know it's little confusing, that's why I suggest everyone please draw by yourself. Now what is the product here? Obviously after 3 carbon, 1 2 3, so this is the answer. Now if you get this question in your exam hall, how can you come up to the right answer very quickly? By the way student, in this case I'll not say there is a very useful tricks. You should remember this concept, and I suggest do more practice, such that practice reduces your time of solving question. You can train your brain in such a way that you can solve the question very quickly, and that is obtained by two. One is systematic study, and second is actually more and more practice. Practice makes both man and woman perfect. So this is the option C. Now here, what is the answer? Now you may think, sir, why not option A? I have already explained. These ring strain, to avoid the angle strain or ring strain, molecule undergo this rearrangement because it gets stability. Now you may think, sir, why not 4-member ring? See, 4-member ring also has ring strain. Agree? Actually, if you look at 6-member ring, it doesn't have that much significant ring strain. 5-member, okay, acceptable, but 3 and 4, they have significant amount of ring strain. Okay, now this much we understand. Now if you think that's an option C versus option D, how can I decide? It's pretty confusing. Count carbon. So this is pH, after that 1 carbon, 2 carbon, 3 carbon, 4 carbon, and you have aldehyde. So total it is the 5th carbon. Now count after pH, 1, 2, 3, 4, 5. 1, 2, 3, 4. See, carbon doesn't match. Why this option is provided? Such that confuse you, because many of students made mistake in this carbon counting. During this reaction they make mistake in carbon counting. That's why I suggest write the mechanism on the pen and paper. Do not always go for the tricks. You can do. If you run behind the tricks blindly, there is a high chance you may take this wrong answer. Okay, so for that purpose such practice needed, and if you do more practice you can save the time in the exam hall. So this is the wrong option. So this is the overall discussion, and this is a very interesting MCQ, very interesting knowledge and information, and I believe this video may be useful to you. And if you really enjoy the content of my channel, please help my channel to grow. And if you have any doubt regarding the logo of my channel, I request everyone please read this part. Your doubt will be clear.